So moving on to the next presentation. So this is from JA Solar. As we all know, JA Solar has a very tight vertical integration. So Jerry Sun, Senior Manager of Product Promotion at JA Solar, is going to talk on the topic like benefiting from tight vertical integration of PV value chain. Jerry?
Hello, can you hear me? I'm sorry, the share doesn't work.
Try just now because
yes. I don't doesn't work as a share. Maybe Mr. Zhang use it.
No, I think the sharing should be with us.
Sorry, I try it again.
Sorry. IT, can you stop sharing so that Jerry can start? Yeah. Now
okay.
It should work.
Okay. Yeah. Sorry. Okay. Sorry. Hello, everyone. This is Jerry from J Solar. Next, I would like to make a presentation about benefiting from tight vertical integration PV value chain. Includes 4 parts. The first part, I'd like to talk about technology status and development trend in brief. First of all, let's review the solar cell technology development roadmap. Before 2015, monocrystalline and polycrystalline solar cells are based on BSI technology. By 2015, P-type cells achieved large scale mass production, significantly improving the efficiency of the cell, and so far it has reached more than 23%. However, with the PERC cell gradually reached the peak efficiency of industrialization, N-type cells have been put into mass production, such as TOPCon, AGT, and BC cells. Next, I will make a multi-dimension analysis of these cells, such as 1 gigawatt capacity equipment investment cost of TOPCon cell. You can see is much lower than that of AGT and BC cells. And the mass production efficiency and theoretical up-limit efficiency are close to that of AGT and BC cells. And the nine silicon cost of TOPCon cell are also much lower than that of AGD and BC cells right now. At the same time, a very important point. These two kinds of cells, TOPCon and AGT, have excellent bifacial power generation performance, but for BC cells with lower bifaciality, its application is limited to the rooftop projects. So I think TOPCon cell is the most effective cell for a long time in the future. For the efficiency and module and power improvement of module, ultimately realized through the improvement of cell efficiency, module technology, and the material optimization, and the increase of the wafer size and the module size. Okay, next part. Talk about DeepBlue 4 Pro module technical feature analysis. Okay, first let me introduce the design concept of this module, the best LCOE. From the formula for calculating the LCOE, we can see that the factors directly related to the modules include the initial investment and the total life cycle energy production. which involves module power efficiency, power generation capacity, and reliability. Specifically speaking, high power and high efficiency module can reduce the BOS cost effectively. This is the key reason why module power and efficiency are getting a rapid boost from 2020. In 2021, several leading companies jointly launched the standard size of 182 modules, including 54, 72, 78 versions. And the standard size of 78 large size modules is 465 millimeter by 1134 millimeters, which has become one of the most choice for the high power modules in the industry. The core logic of this product to be recognized by the market is to comprehensively consider the premise of module production, packaging, transportation, installation, reliability, and product performance. Large size in the high power modules can help customers reduce project construction costs. But the hotspot problem of this module has been the focus of the industry. At the same time, due to the large number of packaged cells, the high open circuit voltage of modules, and the relatively small number of modules connected to a single string at the system, it is not conducive to the reduction of BOS cost to a certain extent. In order to further improve the comprehensive performance of the modules, JA Solar launched the DeepBlue 4 Pro modules based on the industry standard 2465 millimeters by 1134 millimeters module size using 72 cells, which not only reduce the risk of the hotspot, but also reduce the BOS cost BOS cost. And the power of this module can reach 635 watts, and the efficiency can reach 22.8%. Okay, next let's talk about the core technology of DeepBlue 4 Pro. First, for the cell, Bastion Plus cell is an efficient N-type solar cell based on TOPCon technology, which is also based on low oxygen and high minority carrier lifetime, and adopts optimized passivation and contact technologies, super thin busbar and two-sided anti-reflection film technology, and so on. The VOC of the cell can reach 733 millivolts, and the mass production cell efficiency can reach 26%. At the same time, DeepBlue 4 Pro modules also adopt SMBB technology, high density encapsulation technology, high reliability material, and rectangular wafer. For SMBB technology, JA Solar adopts more than 16 busbars according to the module power and the welding reliability. Regarding the high density encapsulation technology, DeepBlue 4 Pro employs the small spacing technology. Compared to the other high density encapsulation methods, this approach balances considerations of cost, power enhancement, production yield, and product reliability. Meanwhile, to improve module reliability and weathering resistance, we also use some optimized material. Next, to talk about the industry mainstream wafer size and the module size. From the date, we can see different module layout with different module lines and thereby adopting different sizes of silicon wafers. In this case, it will cause certain troubles to the entire supply chain and customer applications, resulting in the increase of non-technical cost in the whole industry. Based on this background, GA Solar has launched the 182mm by 199mm rectangular wafers after repeated verification, realizing that one wafer can produce 4 high efficiency and high power versions of modules. You can see here 1, 2, 3, 4, and also make one module is which is compatible with the industry's conventional size of 2278 by 1134. Okay, next talk about the energy yield performance of the modules compared to the PERC modules. For the power degradation performance, the power generation gain is about 1.8% for the high temperature characteristics. The power generation gain is about 1.5% to 2%, and for the bifacial power generation, the power generation gain is around 0.8% to 1.2%, and the last for the low irradiance characteristics, the generation gain is about 0.2%. As we all know, reliability is a fundamental guarantee of the performance of PV modules. DeepBlue 4 modules have passed all standard and enhanced reliability tests, and the test results meet the IEC standard test requirements. You can see from this table. Yeah. Especially with the upgraded module size, we focus on testing the mechanical performance of modules. DeepBlue 4 module demonstrates excellent performance in various load tests for both fixed and flexible mounting solutions. You can see here this test is the result of it is very excellent. In addition, DeepBlue 4 modules have also successfully passed the ASTME 1597 standard test. This PV module product has the ability to withstand repeated exposure to salty atmospheres, immersion in seawater, as well as temperature changes caused by seawater splashing in sunlight, so as to do sufficient verification for the future large-scale offshore applications. Next, as I mentioned above, DeepBlue 4 Pro module mainly includes film dimensions, which can be applied to different application scenarios and meet different customer needs. You can see here this kind of module, the 635 watts is the flagship module in this series. Okay, the third part, customer value analysis. First, let's look at the product performance in outdoor applications. GA Solar and TUI now TUV Line operated 1 year outdoor field test in Yinchuan and Hainan, respectively. The results show that in typical dry, hot climate conditions and typical humid, hot climate conditions, compared to the P-type module, the power generation gain of the N-type module based on battery plus cell is about 3.9% and 2.9% respectively. At the same time, we also have made a detailed analysis of the difference in the power generation gain of N-type modules in these two typical projects. We found that the difference in power generation gain mainly depends on their irradiation intensity, and the power generation gain of N-type modules is more prominent under high irradiance conditions, so that the N-type module will have better power generation performance in high irradiance and high temperature areas. Okay, next, let's look at how DeepBlue 4 Pro module can help customers reduce costs and increase performance. When compared with P-type modules in different application scenarios, project types, and installation methods, the BOS cost of DeepBlue 4 Pro module Pro series modules can be reduced by about 2% to 4.5% and 2.5% to 6%. Compared to the N-type module with regional dimension, the BOS cost and LCOE cost can be reduced by 1.4% to 2.8% and 0.7% to 1.6%. Similarly, for the 635-watt flagship product I mentioned about, in the DeepBlue 4 Pro series, we have made detailed calculation and analysis in different application scenarios. For 2P fixed installation or 1P tracking system, 2P tracking system, the BOS cost and LCOE of this module can be reduced by about 1.3% to 2.6% and 0.6% to 1.5%. The data you can see here. From this data, we can see that in the ground-mounted application scenario, the BOS cost reduction of the tracking system project is higher. This is because that the tracking system includes the electronic control part and the mechanical part, and its cost is more sensitive to the module version, power, and voltage. For C&I plants, the BOS cost and the LCOE can be reduced by about 2.7% and 1.7%. And for the residential rooftop projects, the BOS cost and LCOE can be reduced by about 8% and 4.5%. Through the previous analysis, we can see that this flagship module with 2.465 millimeter by 1.134 millimeter is an excellent solution for full scenario application. Okay, the last part. GSolar is, we know GSolar is a vertical integration PV company. The capacity of ingots, wafers, and the cells is 85 gigawatts respectively, and the capacity of modules is 95 gigawatts. For the N-type product, the capacity can reach 57 gigawatts at the end of this year. Of course, technology innovation is the core of the health development of an enterprise. Solar invests a lot of funds and resources every year to develop and resolve advanced technologies, and will continue to strengthen R&D work in the future, promote the mass production of new products and technologies, and provide the better LCU module solutions for the industry and customers. Okay, that's all. Thank you for your listening.
Okay, thank you, Sun. Thank you very much for this very nice presentation. We don't have a lot of time, so I will ask one question from my side. You also touched this topic of reliability a little bit, but with more and more application scenarios for PV modules and more harsh environments, as we see as the effect of global warming, how can the reliability of PV modules be guaranteed?
Okay, module reliability can be, I think, guaranteed by both product side and the test side. On the product side, reliable cells, advanced module encapsulation technology, excellent module encapsulation materials, and optimized module layout design are required. On the test side, it is guaranteed by indoor standard aging test, severe aging test, and outdoor field test. For example, as mentioned about, we need to pay actual attention to the risk of mechanical performance when the module size is enlarged, especially in relative harsh environments. We focus for the DeepBlue 4 module, we focus on the various mechanical tests. Okay. In addition, the field test is also very critical for the new products and technologies. All of G Solar's new products and technologies will be fully verified by field test clients before they are put into mass production. For example, we will cooperate with third-party organizations to operate our field test of the N-type Passion Plus products for at least 1 year in 2021 to fully ensure that the product's power generation, performance, and reliability. This is my answer. Thank you.
Okay. Thank you very much. And please stay back, and if there are any questions in the chat window, please try to answer them.
Okay.